right now. So you're not missing a thing. Okay, we're going to do volume. Today we are going to do discs and washers. Okay? Monday, we're going to do probably cross sections, because there's 3 types on your exam that you could run into. You will not run into all 3. I have no idea which ones they're going to give you. Certainly they're going to give you area. They always give you area. And then they're going to give you volume. It could be as simple as what we do today that you won't find simple, or it could get more complicated. It could be a cross section, or we could rotate these curves around axes other than the x and y axis. And we'll probably do those Tuesday. I'm not sure which one to do which day, but that's okay. And then we're done with the new material. Your assignment is whatever we don't finish on this worksheet of the examples we're going to do. And Adam, I think you need to sit up front, please.
Adam, bring it up here.
And then to work on that big, thick yellow packet of the AP free response. Yes. Okay. So, and you won't be able to do all of it. If it says it has a square cross section, I'm not covering that today. You can't do that. If it says rotate around y equals, I got to bring something up. If it rotate around y equals 2, we can't do that either, although you might be able to figure it out because it's all geometry. And let's see. Here we go. Where's my email? I'll show you what we're going to... Where's all that stuff? Also what we're going to do here, and... this one. This is her husband found a website, and I found a website. Okay, so what we're going to do is I'm going to first start with her website. If I can figure out which one it is. Oh, there it is. Oops. I don't like how this works. Okay, guys? Look and see what's happening here. We are going to I'm going to take one of these. This is the region right here, just a plain region. It's a weird shape. And we are going to rotate it around an axis. And we're going to get volume. So yes, this is 3-dimensional. Try that one. Why is this not working?
How are we going to draw it?
It's tricky. Oh, it is. Replay the animation. Why can't I do this one? I can do that one.
I can't draw in 3D.
Okay, there it goes. But that's going to be the challenge, is drawing it. So you can see that plane region. It's hard to see. This, I said, it's why we had to close the blinds. But the plane region is rotating around the axis. We're going to do this ourselves. Now, can I go back to... There's that one. Do you see it?
Not even math. It's just art now.
Oh, this is all math. It's geometry. Okay, there it is. Come on. There it goes. That's a weird shape, but look at it rotating around. It's like those wedding bell decorations. So you rotate them around. That's what it is. There's a cool one coming up, too. So it kind of helps to see what we're going to look at. That is so annoying. Look at this next one we're going to do. That's kind of cool, isn't it?
It's a 5.
Make it bigger.
I'm a big fan of a good
It's a sine curve that's being rotated. Look at that. What are the cross sections? If you were to take a slice this way, what are the shapes of the cross sections? They're circles. That's as hard as the geometry gets. Well, it gets harder because you have to find the radius. Okay, so now we can go to my website. That's not what I want. This one. Okay. Okay, guys? This is a horizontal line that has rotated around the x-axis, And that's what your cross section looks like. By the way, I'm going to write on this, but I'm going to lose it. But can you see the cylinder here?
Yes, ma'am.
Yeah, but that's the easy part, because that's the calculus. The hard part is the geometry. So I can slide this, and you can see all these little discs are the same, aren't they? Okay, Nick, I need you up here. They're all the same. Now we can change this to just a regular line with an angle to it, and what happens to your little cross sections? Yes, if I were to fill this up with quarters that are getting bigger and bigger, I would get a cone, wouldn't I? But the cross sections are changing in size. What if we have, and we'll come back, what if we have a parabola? Can you visualize what that looks like? Looks like a horn, doesn't it? We'll do some of these. And so what is the cross section? It's a circle. And then we're going to go over here and say, what happens if we put a hole in the middle? That's called a what? It's a washer. So those are the two things that we're going to do. So let's go back and start with the first one. The challenge is going to be, of course, graphing it. Okay? And so I should know what that looks like. Consider that curve bounded by the, I want to consider curve, that one, bounded by the curve, the x-axis, and the line x equals 3. And I'm going to rotate around the x-axis. So you need to draw these with me. Oh, you'll have to do the best you can, because if you don't draw them, you're not going to get the right pieces. So we're going to rotate around the x-axis. Sort of, oh, it was right. No longer. But now the next question is, what does that curve look like? Is that straight?
Yeah.
It's an upside down parabola. So I would like to graph it, and I'd like to find out where the intercepts are. So I'd like to find out when y is 0, what the x values are. Those are the zeros of the function. Whoops. Said 0 and wrote a z. Okay? So you should be doing this with me. And so we're going to factor out what? Negative x. And I'm left with x minus 4. So where are the zeros? It's 0 and 4. So I'm going to plot those points. And now I'm going to put 4 over here. We are going to take this curve and rotate it. But let me first draw the curve. So it's this. Do you know where the vertex is? It's halfway between the 0 and the 4. So it's going to be a 2. And I'm going to bound it by the x-axis, the line x equals 3. So let's put x equals 3 in there. Looks like it's about here. About. Close enough. And so I'm going to take a red pen and I'm going to outline it. So my boundaries here are going to be the curve, this line right there, the x-axis. So it's this region in there. I'm going to color it. I don't know if that's a good thing or a bad thing. It's this region right in here. So that's the shape that we're going to rotate around the x-axis. We always work with the original function. Okay, Olivia? So you need to draw this. The only way you're going to get good at this is to draw it. And people who can't do it have problems with that. Okay, let's see. Let's see if I can cheat a little. Okay, we are going to flip that. And there it is.
So we don't have that. Yeah.
No, I know you don't. And they don't have smartboard software on the iPads. It would be nice if they did. And so I'm going to try to make this three-dimensional as best I can. I think this looks like an eyeball. Yeah, think of slicing an egg. They're in orange. What are the cross sections? Orange, and they're all different size discs, aren't they?
Why'd you draw another little oval?
I'm trying to make it look three-dimensional. Because it's rotating around at you like this, just like that picture I showed you. It's taking this curve right here, rotating it around here. Just think of this of those barrels. When you rotate that,
I can never tell what dimension I'm in.
we're only in 3.
I can never tell when I get to the
Okay. Can you see that? Can I do this?
It's called LSD, the government interrogation tool.
Go over to France.
I'm Cubans.
Oh, there it goes. Okay, you guys. There's my disc. It's like a quarter. What shape is it? It's a circle, and here's the thickness. I call it the thickness. Last class wanted me to call it H. I don't care. I don't ever talk about the height of a quarter. I talk about how thick it is. I got a washer here. I don't have any money in here. But this is what we're talking about. The thickness is just this little bit here. So if it's sitting here, is the thickness going to be changing X or changing Y? Yeah, changing X, isn't it? Because we're looking at this distance from there to there. That's this little piece right there. That's the change in the X. So let's find the volume for one of the disks. Well, the volume for one. Well, how would you find the volume of a little cylinder? Adam, up here, please. No, you're not. How else Luke can come? Luke, you want to come up? Good. It's pi what? It's the area of the circle, base, times how thick it is. Pi radius squared times the thickness. You want to call it H? You can call it H. Let me call it H. Okay. Now, this is where the geometry comes in. You have to figure out what H and what R. What those are. We already said this thickness was delta X. Look at your picture. Here's the radius. What value is the radius? No, it's changing. It's on this curve. It's the X or it's the Y coordinate. It's the Y. And you know, we talked about area as these values will always be opposite. So the volume for one of these little disks is going to be pi y squared delta x. R is changing. It's the y coordinate along that curve. If it's a horizontal line, if that's at 4, for instance, R equals 4. It's a constant. And you know how to do that without calculus. I can't do this without calculus. Okay. I still haven't put the function in. So, Luke, what do I do next? I have to integrate this. No, we integrate. What variable do I want now to keep? I want x's. So what was my function? My function was y equals minus x squared plus 4x. Right? Hey, Artavan, what am I going to do with that? I'm going to put this in for y and see what I get. Well, we still got to get limits of integration before we can integrate. Well, let's pull the pi out because I can. And so this is minus x squared plus 4x squared dx. Okay, guys? Question? If you can look at last year's exam just to see how easy or hard this was. It was out of calculator. Now, what are the x's between? Because this is telling me I want x, not y. 0 and, not 4, but 3. You really need a nice picture. Now, can I do a U substitution of this work? Well, that's another question. Why would I need to? because I can't just square that over 2 because of the chain rule. This is composite. You can't do that. So I would need the derivative of this embedded in there, and that's not there either. So how about if we just multiply it? Now, do you guys know the short, easy way to do multiply to square a binomial? Only if you have a CAS, and most of you don't. So you square the first term. What's minus x squared squared is x to the what? 4th. To get the middle term, you multiply these together, and you double it. You guys have seen that? You multiply these together, so it's minus 4x cubed, which we double it. So it's minus 8x cubed, and then we square the last term, plus 16x squared. Is there any problem finishing this? Because I can go into the setup with the next one. Do you know how to integrate that? Because I can't integrate it as written. I can't just make it this thing to the 3rd over 3 because I don't have the derivative of that. Now you can integrate it. Sure.
Awesome.
It's just geometry. Okay, here's the calculus. This is tough, isn't it? It's x to the what? 5th. Now, some of you are going the wrong direction. You're taking the derivative. Minus 8x to the what? 4th over 4. Plus 16x to the 3rd over 3, evaluated at 0 and 3. This is free response. You're not quite done, but almost done. All you have to do is substitute those values in. So it's pi, and I'm not going to multiply that out, because if I multiply that out wrong and I say it's 15, I'm in big trouble. It's 3 to the 5th over 5. I'm not going to get the point. Minus, I wouldn't even divide the 8/4. I mean, I'm going to because it's not hard. It's 2 times 3 to the 4th. What's 3 to the 4th? Anybody know that quickly? Matt? 81. Because it's 3 squared times 3 squared. Okay, are you guys doing math back? Is that math? Not right now. Plus 16, and it's 3 cubed over 3.
That is wrong.
Okay, minus, you guys, don't assume that just because that last value is 0, that this is going to be 0, because it might not be, but it does turn out to be 0. So we're okay. But always double check it, because it's not always 0. It depends on what the function is. Now, that's good enough for the free response part of the exam. Okay, Andrew? Don't need to multiply it out. Don't waste your time. It's a timed exam. Don't waste your time multiplying it. If you multiply it out and you do it wrong, you've wasted time and you've lost your answer point. So we don't want to see you do that. Okay. Not play very hard. Let's do another one. The hard part for you is going to be graphing these. Notice we are not assigning a book assignment. Okay, we're going to rotate this over the y-axis. Okay, you ready? Now you should know what your basic functions look like. Hey guys. Okay, Arden, turn the page. And what does it look like?
It looks like a...
Well, what is this x? It says x equals 2 divided by y.
I have no idea what that is.
Well, you actually do. So x times y equals 2. Solve for y.
2 over x.
Okay, do you realize that 2 over x is 2 times 1 over x? What's 1 over x look like? It's a hyperbola. It's a hyperbola. 1 over x looks like this. 2 over x just makes it, stretches it. Well, who cares? Well, I don't really care. Okay, I'm going to take this curve, 2 over x, and I'm going to bound it by, I'm not going to take this bottom part here because it's bounded by y equals 1. Oops. So y equals 1 might be here. And then it's also bounded by the line y equals 4. And the line x equals 0. So let me get my pen out and let's trace it. Okay, you ready? Question? Artivan, question? Okay, so we have this curve, x equals 2 over y. We have the line y equals 1, the line y equals 4, and we are going to take this region. So we're going to bound it by this line, this curve, this line, and this axis. Yes? Oh, yeah, sorry about that. That's easy to fix, though. Okay. That's the shape that we're going to rotate around which axis? The y-axis. By the way, no, it's not going to look like that, but it's, when you do this, make sure you read carefully to do the correct axis. Even on our tests, some of you will rotate around the wrong axis. Okay, Jimmy? Andrew? So I'm going to take this and cheat a little. And I'm going to, I'm missing part of it, but that's okay.
It's like a nuclear reactor.
We are going to flip it. Next week does.
Flip it up to Y.
We looked at called it a volcano.
Or a volcano.
Well, let's put the slide. Where are the slices going to be this time? Are they going to be?
Sideways.
Yeah, they're going to be the other way around.
How far down?
They're going to be like this.
Are we in the third dimension?
I am. I don't know, are you in the fourth dimension? That's the third question. Do you see it? Do you see the three-dimensional picture there?
Fall back. I need a kick out of this one.
Okay. Can you see the three-dimensional figure now? Oh, you have nice pictures. You need to have the nice picture. You're not going to know what to do. Beautiful. Hey, guys.
The top stopped spinning. It was wobbly. No.
Okay, guys. There's the disc. Can we get bigger? Whoops. Is that I always like to do the thickness or the height, whatever you want to call it. I want to know that. This is all magnified.
That's changing Y.
Okay, so that's the change in y.
Oh, let's see. I know the equation.
We're not going to worry about the equation yet. First, the volume, guys, is pi radius squared times the change in y. Let's put the radius in. This is the radius, so I'm going to put it in up here. This is the radius. Which coordinate is the radius? R is equal to x. It's all geometry. So this is going to be x. Okay? So the volume for the whole thing, we're going to add it up. It's pi x squared, and it's dy. And what variable do I want to keep? The y. Because it's the radius of my cylinder. I will. No, it's not 2 over x. Here's the radius right here, right? That's the x coordinate on my curve. Okay, so I want to have y's in there, and it started with what? X equals 2 over y? Was that what we originally started with?
Yeah.
Why don't we just substitute that in? Right there. You want to keep the y's, not the x's. That's why the students, when I grade these, they don't have a differential. It's okay, we don't mark it off. However, they usually don't have the right function in there because they didn't bother to put the differential in. So the volume is going to be, see, this is where I put now my function in. It's 2 over y squared dy. And Natalie has a question. What? Because of the constant. And I like to get the constants out of the way. Okay, what are the y's going between? Let's look at our picture. Oh, this is easy. 1 to 4. I put it there. This is where we get graded. That's where you get the grade. The rest of it's just working to get there. Okay, let's do this because I don't want to see you do this wrong. So what can I do with this 4 that's in there? Pull it out. So the volume is equal to 4 pi, because 2 squared is 4, and I pulled it out. So I'm lazy. And this is from 1 to 4. Is that going to give me the log? No. All you know is this. X to the n, 1 over x, which is a log. I know it kind of looks like 1 over x, but it isn't. It's 1 over x squared. And e to the x, plus the trig. But I don't see any trig, so we're in luck. So this is good. Let's integrate this. Some of you could see it right away. Some of you can't. And also keep track of what you're doing. We haven't integrated. I'm just going to write it like that. And then I'm going to integrate. So what's the volume equal to? 4 pi negative y to negative 1. And we will evaluate at 1 and 4. And once I put the numbers in, it's okay. We're going to finish this problem. But once you put the numbers in, you're done if it's free response. This would not be free response. This would be multiple choice. And yes, there'll be some on multiple choice. I just haven't had a chance to get them together yet. So it's negative 4 to the negative 1. Then it's minus a negative y. So it's negative 1. I don't like that, because that's not right. It's subtracting, and then it's minus, no, it's a positive 1 to the negative 1. So what's the, and that's good enough. But we're going to do this because we can. So what's this first fraction? Negative 1/4. And this is to become, 2 negatives become a positive 1. What's 1 take away a 4? 3/4. What happens to the 4s? Go. So the answer is 3 pi. And if you need to come in for extra help, come. And it's Friday. Who cares? It's Friday. How many Fridays before the exam? Not very many. No. That's the point. Okay, ready for the challenging type problems now. Is that one okay?
Yeah, that was good.
That wasn't too bad. But if you don't draw it, you're in trouble. Especially when it comes to this next one. Now, I'd like to get through all of this today. If I don't, this becomes homework. So we get it done. We don't have that homework. But you'll work on the free response questions. Again, the challenge is drawing it. Okay, ready? Okay, Zach, are you ready? Okay, find the volume of the solid created by rotating that figure. I'm going to bound my region by these curves. Well, y equals x squared is pretty easy. And we're going to rotate around the x-axis. That's straight. Okay, ready? Y equals x squared looks like this. What does y squared equals 8x look like? It looks like a square root. Just the top part, because the parabola, which looks like this, and the square root, which looks like this, because you have plus and minus, it's just that region we're dealing with. It's the only place to intersect. So then I'm going to do this. And I'm going to take that little region there and rotate that around the x-axis. And so I'm going to trace this out. I'm going to cheat a little. Yeah, it's not fair, is it? Oh, I did a pretty nice freehand one on that. Looks like a flower, doesn't it? It's on its side, but that's okay. So this is the opening here, and then inside here. And there is, actually that's solid, there's a hole. I don't think that looks too bad. See why we had to have the lights off, so we can see these. Oh, that's not bad. That's a, what's the shape? It's a washer. It's a washer. Where's my little... It's this. It's going to have a hole in the middle. So let's go back and see if I can find that video.
What video?
I'll find it. This one. It's that. It's a washer. That's what this is. It's a washer. So let's go to a different shape. There's that type. Now it gets to be a full disc at that end, but what happens here?
The hole is getting bigger.
Right. I know I can't. You don't see the three-dimensional shape so much. What's the next one? Oh, an odd shape. Kind of like what we're doing, except this was curved. Okay, guys? Now, what is the height of that washer, or the thickness? That's this piece right here. Delta X or delta Y?
The washer.
Or the washer. The hole and the outside have the same thickness. Delta X or delta Y? Delta X. That's the secret to doing these, well, in my mind. Okay, so this distance here is delta X. So, you can memorize this if you want. I just work it out. How would you find the volume of a washer? Okay, my washers aren't the prettiest washers in the world, but they might work. How a washer looks like this.
It goes around
Well,
like...
what do you use them for?
I use them all the time building things, but we're just trying to find the volume. Got to put a washer on there. Okay, so how are you going to find the volume of this? It's the big, it's the area of the base, so it's the big, shh, you guys? Guys? Okay, Artivan, it's the big radius. I need to get rid of the, I need to make a hole there, so it's pi, big radius squared, minus the little radius, I'll call that little r. What? And this is h, which you always wanted to call h for the thickness. The hard part is figuring out what the radius is. Now, no, can I factor the pi's? Yes. So it's r squared minus little r squared times h. What is my h here? My thickness. It's delta x. Is r squared minus little r squared, Cole, is that equal to r, capital R minus little r quantity squared? Adam?
Yes, you do the y's.
Are these the same?
Oh.
No. By the way, I'm going, you guys, you need to be paying attention because we're reviewing for the exam. We are not coming back to this after spring break. We're done. We're done with this piece. So what's the biggest mistake students make? They don't want to, they might not even write it that way. They write it this way. That is just plain wrong. Once you do that, you're done. You're out of the game. So you don't want to do that. It's the area of the big circle minus the area of the little circle, and you can't do that mathematically. It's bad. Okay, so I'm going to move this, and now we have to figure out a radius. So the little radius, now I better label these. This one was y equals x squared. So call that y1. I don't care what you call it. That was the parabola. the upside down parabola was y2 equals the square root of 8x. Is that okay?
Yes.
Okay. Artemis, what's the big radius? Here's the big radius. It goes up here. Which y value is it? My y1 or y2?
Y1.
Definitely Y.
It's y2. This is what I'm saying. You just have to look at the geometry.
Well, I got really. I wanted to look at it, but everything.
Okay. What is the little radius?
Y1.
Okay, so we'll go ahead and put those in. I haven't put the function in yet. This is just the generic plan. We're going to add them all up, so we're going to factor out the pi, because we can. And a big radius was y2 squared minus y1 squared, and this is going to be dx. What variable do we want in our integral? I want x's. If you don't put the dx in, you'll be tempted to just do what that says there. Okay, what's y2? y2 was this one. So we're going to put that in and we're going to square it. I'm going to do one thing at a time. So it's y2 is the square root of 8x, and we're going to square it. What's, yes. You know what, I already knew that because it was y squared equals 8x from the very beginning. But now the other one is y equals x squared, and so I'm just going to put that one in. But what do you have to do with this x squared? Square it. Is it easy to think that you've squared it when you look at the 2? Yes. And that's a dx. And now the hard part is where do they intersect? So we have y equals x squared, and we have y squared equals 8x. That is a nonlinear system, and it's a non-graphing calculator problem. Where you see y, we'll just use substitution. Y is equal to x squared, so guess what I can put in right here? X squared. What am I going to do with that x squared? I'm going to square it. Now, some of you, this is x to the 4th equals 8x divided by x. Can you do that? What if x is 0? Can you divide by 0? So don't do that. Factor it. Remember, we solve every equation by setting it equal to 0. And if we factor it, it's x cubed minus 8 equals 0. So x equals 0, or you could do this by inspection, 2. So, this is the system right here. It's a system of equations. You got to solve that. I do guess and check, because they don't check for your work on that. They just check to see if you got the right answer.
Why did you square x squared again?
Because I'm going to put y in, and y is x squared. I'm going to put it right in here to y squared.
Oh, why are we
Because we have to know our limits of integration.
Oh.
So you can see one of them pretty easily. What's this x value here? What's the smallest x this is going to be? 0. And it's going to go to this x value, which we now have decided that was 2. We're trying to find the volume of that strange shape. So that's 0 to 2. And I would simplify that before I integrate, or I'd be in big trouble. Because this is what? 8x minus x to the 4th. That's not so bad to do, is it? Right? Not so bad to do. And if you want to start working backwards, start with 2011 and do 2010. Those are the 2 years that did not have a calculator. You will not be allowed a calculator on this problem this year. It's an area volume problem every single year. This is the easiest one to prepare for. That and the differential equations, I think.
And they don't draw the picture.
Sometimes they do, sometimes they don't. Look at your yellow packet. You'll see some pictures, some without pictures. Usually they draw the picture because their goal is not to test you on, can you draw the picture, but can you find the volume? So let's try the next one. We are going to do the same thing and rotate around the y-axis. And some of you say, well, it'll be the same answer. No, it is not. So I'm going to draw that. So you guys draw it. And this is all we have left to do today. Then you should. I know it's going to be a gorgeous weekend, but the weather's only going to get better between now and May. Oh, at least I hope.
It's only March. It's so bad.
I know it's going to be 80 degrees tomorrow. But anyway, you should. You know, if you start working on these problems, is that crooked? It's 15 minutes of free response question. If you've already done the areas, you've already done 5 minutes out of that. You know, give me a half hour. So I'm going to take this curve and this curve. And I'm going to flip it. I like this part. I like the art part. And now, yeah, more butterfly wings. We'll rotate it around Y. And when I draw my radius, I always go to the original curve, never to the image. So let me try and draw a slice here. It's going to look similar to the other one. It does have a different volume though. There's that one, and there's this one. And there's a hole in the middle. Should I shade in the solid? And I'll put those links for those websites so you can go and look at them yourself up on Schoology. I like art. I think Natalie likes art too. Okay, do you see your washer there? Okay, easy. Volume for 1 is pi, and it's big radius squared minus the little radius squared times the height. This distance here. Delta x, delta y. Yeah. So if you like geometry, this is the time you've been waiting for. Now, what's the big radius? That's the measure from your axis of rotation out to the outer graph. I'll call that x1. That's the parabola. Is that okay? That's the big one. Where's the little one? The little one's from the axis of rotation to the inside curve, which, by the way, that's y equal to, what was that? Square root 8x, right? Okay, call that x coordinate, because that's the x value there. Call that x2. So I'll put x2 here, and I'll put x1 there. See if my method works today. Okay, ready? So the volume is pi. And we are going to integrate the outer radius, which is, which one? X1 or X2? X1. It's just a lot of keeping track, minus the inner radius, which is X2. And then this is dy. Notice I haven't worried about what the function is, because I don't care. Well, now I do. What variable do I want here? X or y? I want y. So when I look at this, I have to solve this for x in terms of y. What's x equal to? If y equals x squared, that's x1 squared, then x1 is equal to the square root of y. If I have y squared equals 8x2. What's x2 equal to? I got 3 more minutes, but we'll be done in 1. Yeah, and you just substitute it in. There's so little calculus. It's all geometry. So the volume is pi. We're almost done. x1 squared is the square root of y squared, or just y. x2 squared is y squared over 8. Don't forget to square the 8. Okay. And then And what? We have to integrate on the y's. Now you're starting down here. Now you know what? One of the answers on the exam is going to be with the x-coordinates. What's the bottom y coordinate? 0. Now, we already did some work here. We found that the x-coordinate was 2, remember? If x is equal to 2, using either one of these equations, what's the y value? 4. Okay? Then next week, we'll do cross-sections that are not circles. They're weird-looking things, but that's okay because we don't care what it looks like. Just care about the cross-section, and then also rotate around other lines. I think we'll do the rotating first and cross-sections Tuesday. So you guys have a great weekend. I think, yeah.